So, good night. My name is Marques, and I will talk about clustering as a homework for the discipline of special topics and algorithms. And I hope you enjoy. What is clustering? Well, given a set of points with a notion of distance between points, we want to group the points into some number of clusters so that members of a cluster are close or similar to each other, and members of different clusters are dissimilar or different. Uh, Usually, points are in a high-dimensional space, and similarity is defined using a distance measure like Euclidean, cosine, Jacquard, or etc. Um, the notion of a cluster cannot be precisely defined, which is one of the reasons why there are so many clustering algorithms. But there is a common denominator. We have a group of data objects and we want to deal with it. This is basically a type of unsupervised learning method. An unsupervised learning method is a method which we draw reference from the datasets consisting of input data without labeled responses. Okay, so we have here um, a large set of points, and we want to uh, merge them into clusters based of their similarities. Okay, we'll talk more about that after. Here I'm showing data that do not fit in any cluster. This data and this data. If an object don't fit in any cluster, it means that it has no similarity of any of the data, and it is called an outlier. So we have clusters with members uh, with similarity, and members that do not fit in any cluster are called outlier. So that's what we want to do. We want to take a lot of objects and put each of them in clusters based on their similarities. Okay, this is clustering. But why clustering? Well, clustering is very much important as it determines the intrinsic grouping among the unlabeled data present. Uh, there are no criteria for a good clustering. It depends on the user and what is the criteria they may use which satisfy their need. For instance, we could be interested in finding representatives for homogeneous groups like data reduction, in finding natural clusters and describe their unknown properties, uh, being natural or unnatural data types. This algorithm must make some assumptions which constitute the similarity of points, and each assumption make different and equally valid clusters. Also, we have a lot of cluster models, which we'll see after. The first of them is the density-based models. Uh, the density-based clustering works by detecting areas where points are concentrated and where they are separated by areas that are empty or sparse. Points that are not part of a cluster are labeled as noise. And one of the most common clustering algorithms uh, is the dB scan. So here we have a lot of points uh, close one to another. So we pick this pack of objects and make a cluster of them. Here, the same thing. We have a lot of points close one to another. Then we pick 10 and make a cluster. And these nodes that are uh, not close to other points, these points belongs to uh, zero clusters and are called as noises. Okay, this is the density-based clustering. Another method of clustering is the hierarchical-based methods. Um, there are two types, the agglomerative and the divisive. The agglomerative or bottom-up, initially, uh, each point is a cluster, and repeatedly we combine these two nearest clusters into one. So, uh, at begin, every object is in one cluster. So we pick the two closest, join them, and form one cluster of the two clusters. And we take this cluster and join to this cluster, and we'll join until we have a, a, a arbitrary quantity uh, of clusters. Okay, uh, and we have the device of top-down method, in which we start with one big cluster with all the objects, and we going to split this uh, this cluster to two. After we split to 4 to 8 and so on. This is the hierarchical based models, and the most common algorithm to this type is CURE, or clustering using representatives. Um, Another method is partitioning methods. These methods partition the objects into k clusters, and each partition forms one cluster. This method is used to optimize an objective partition similarity, such as when the distance is a major parameter. The most common algorithm for partitioning methods is k-means, and we'll see more about that after. Here we have a few of applications of clustering in different fields. We have applications in marketing, where it can be used to characterize and discover customer segments for marketing purposes. We can use in biology, where it can be used for classification among different species of plants and animals. We can use it in libraries, where it can be used in clustering different books on the basis of topics and information. In insurance, it is used to acknowledge the customers, their policies, and identifying frauds. And we can use too in city planning, where it is used to make groups of houses and to study their values based on the geographical locations and other factors present. Okay, so now we'll talk about how k-means works. Suppose our goal is to find a few similar groups in a dataset like this. We have a lot of objects, and we have to find similar groups uh, of these colors that this colors is showing for us. This is a dataset, this is a dataset, this is a dataset, but we don't know yet, and we will find with k-means. So k-means begins with k randomly placed centroids. These are the centroids. Centroids, as the name suggests, are the center points of the clusters. Uh, for example, here we're adding 4 centroids, and then we will assign to these centroids uh, to any existing data uh, that is closer to them. So each data is will be associated with the nearest centroid, and these associated objects will become a cluster. So we have a cluster here, a cluster here, a cluster here, a cluster here, uh, all with all of them with one centroid. Next, we will move the centroids to the average location of points assigned to it. Um, so we pick the centroids and move them to the average center of the cluster. Okay, so next we will uh, remake this path various times until the assignment between multiple consecutive iterations stops changing. So after we run this algorithm a lot of times, uh, in a time, uh, the the clusters will not modify anymore. So we we allocating the centroids in a point that we can get the clusters. So here is the final situation. This is k-means. Okay, and that's it. I hope you enjoyed this video. If you enjoyed, please slap like now, put a comment.